Welcome my viewers as well as the students. Today's class I am going to explain to start the simple regression analysis. This is what I am going to explain in the previous class. On another channel I have explained a simple correlation in quite detail. Today I shall be explaining this linear regression analysis, and that too is simple regression. It's not a multiple regression, it's a simple regression analysis. With two variables x and y, we can conceive a regression equation of y on x. Let regression equation of y on x is y equals alpha plus beta x plus e. This e is the random variable, this random element. Now, in regression analysis, what we are supposed to do, in regression analysis, we obtain numerical values of the parameters. These two are the parameters alpha and beta. The numerical values of alpha and beta would be found by using least square method. So, there are various methods for obtaining the parameter estimates, but the most popular method is this least square method, which will be explained today itself. So, the numerical estimates of this alpha and beta, these two parameters would be obtained by using least square methods. Now, this regression analysis has three objectives. Firstly, to obtain numerical values of the parameters of the function. Here we have two variables y and x. X is the independent, y is the dependent, and this corresponding to these two variables we have the two parameters alpha and beta. So, first objective of regression analysis is to obtain numerical values of the parameters. Second objective is to obtain the additive components of total variations in dependent variable y. Yes. So, when x changes, y changes, but the change in y is not totally on account of x, rather some another element, this a, is also responsible for the changes in y. So, through regression analysis, we obtain the additive components of total variations in dependent variable. This is total sum of squares. This has two components, explained sum of squares and residual sum of squares. These things are found by regression analysis. And number 3, to forecast the future value of the dependent variable for any arbitrary value of the independent variable. So, for any value of x, arbitrary value of x, y can be forecasted if we do have the numerical values of alpha and beta. This regression analysis, let me tell you, this word regression was used by Francis Galton. He was a biometrician with the measurement of human body, biometrician. Regress means to get back, to retreat, and this meaning of regression has nothing to do in statistics. What Francis Galton meant, that if first generation, second generation, third generation, he found that the heights of this third generation gets back to the average heights of the previous generations. So, regress means to get back. Here regression was used in this sense, that the height of this generation tends to get back to the average heights of the previous generations. In this context, Francis Galton used this word regression. But the use of this word regression in statistics is absolutely accidental. It has nothing to do with this meaning of regression, what this gentleman had used, Francis Galton. So anyway, so this is what about the regression analysis. Now, what is least square method? This is I am going to explain just now. Now, we must come on the least square method. A little bit of differential calculus would be used for maximizing a function. Let the model was y is alpha plus beta x plus e. Let estimated line is y cap is alpha cap plus beta cap x. So E is defined as y minus y cap. In the diagram, this straight line which passes through the intersection of x bar and y bar, this is least square line, and these are the scatter points around this line. Now there are various points. Now let us consider this point A. Here is the value of y. It is y cap and it is y bar. So y minus y cap, this is E, residual E. So the E is defined as y minus y cap. This is what we have written here. Now this formula or the least square would be explained in two versions. Non-deviation version, non-deviation form. Here E is y minus y cap. So take summation on both sides and get squared on both sides. Hence, summation E square is summation y minus y cap square. Now here it has to be explained that in least square method, this summation E square is minimized. This summation E square is minimized with the help of differential calculus. This could be written as y cap is alpha cap plus beta cap x. So minus alpha cap minus beta cap x and square. So this summation E square is to be maximized with the help of calculus. Now to minimize summation E square, first order condition is delta summation E square by delta alpha cap equals 0 and delta summation E square by delta beta cap summation 0. So these two partial derivatives has to be equated to 0. First of all, sigma summation E square is differentiated with respect to alpha cap and then with respect to beta cap. So delta summation E square by delta alpha cap is, this is being differentiated. So 2y minus alpha cap minus beta cap x minus 1, 0. And delta summation E square by delta beta cap is summation 2y minus alpha cap minus beta cap x into minus x equals 0. So these are the two derivatives with respect to alpha cap and beta cap. These two equations have to be solved. Now from 1, this 2 and minus, so minus 2 would not remain inside the summation sign. So from 1, minus 2 is taken outside. Then we have summation y minus alpha cap minus beta cap 0. Now this is being left out. So inside one summation sign we have three terms. Let us separate it. So summation y minus summation alpha cap. Alpha cap is a constant, and whenever we take summation of any constant, summation is ignored and constant is just multiplied by n. So minus n alpha cap minus beta cap summation x 0. Change the side, these two are taken to another side. So n alpha cap plus beta cap summation x is summation y. This is first normal equation. Now from 2, once again minus 2 is taken outside. So inside the summation sign we have y minus alpha cap minus beta cap x into x equals 0. Once again, minus 2 is ignored. So these three terms have to be multiplied by x. So this is summation xy minus alpha cap x minus beta x square 0. Now let us separate these three terms. So this is summation xy minus alpha cap summation x minus beta cap summation x square equals 0. These two are taken to another side. So it is alpha cap summation x plus beta cap summation x square is summation xy. This is second normal equation. So in the non-deviation form, we get these two normal equations, and these two normal equations could be written as, hence we have n alpha cap plus beta cap summation x is summation y, and alpha cap summation x plus beta cap summation x square, and it is summation xy. If these two normal equations are solved for x and y, we shall get the value of x and y separately, and in that case we shall have the value of alpha and beta cap as. So by solving we get beta cap is n summation xy minus summation x summation y, and n summation x square minus summation x whole square. This is beta, and from first normal equation, this one from first one, so if n alpha cap plus beta cap summation x is summation y, now just divide whole equation by n. So divide by n, we have summation y by n equals n alpha cap by n plus beta cap summation x by n. Now this summation y by n has become y bar, n cancelled, alpha plus beta cap, once again summation x by n is x bar. We have to find out the value of alpha. So alpha cap is y bar minus beta cap x bar. Yes, so this is the value of alpha and this is the value of beta. So in least square method, this is how we get the values of alpha and beta in non-deviation form. Now I am going to explain this in a deviation form. This is right now I am going to explain. Now in deviation form, we shall deviate each variable from its own mean, x from x bar and y from y bar. So small y is y minus y bar, hence capital Y is a small y plus y bar. Similarly, small y cap is capital Y cap minus y bar. So capital Y cap is a small y cap plus y bar. Hence E is defined as y minus y cap. So y minus y cap, so a small y plus y bar minus a small y cap minus y bar. Y bar gets cancelled. So a small y minus small y cap. Now this small y cap is defined as capital Y cap or minus y bar, that is alpha cap plus beta cap x, or minus alpha cap minus beta cap x bar. So y cap minus y bar, alpha cap gets cancelled. So beta cap x minus beta cap x bar, beta cap is taken common, x minus x bar. So this is beta cap small x. So a small e could be written as small y minus a small y cap, a small y minus beta cap x. Hence summation e square is summation y minus beta cap x square. Now this summation E square is once again minimized with the help of calculus. So first order condition is d summation E square by d beta cap 0. With respect to beta cap, this has to be differentiated. So 2y minus beta cap x minus x 0. Once again minus 2 is taken outside. So minus 2, we have y minus beta cap x into x 0. This is left out. So we have this one. So it is summation xy minus beta cap x square 0. Now let us separate these two terms. So this is summation xy minus beta cap summation x square 0. So this could be written as beta cap summation x square is summation xy, hence beta cap is summation xy by summation x square, all in deviated forms. This is small x, small y. Now this formula could be expressed in the form summation xy. So x minus x bar, y minus y bar, and divide it by n from our own side. Denominator summation x minus x bar square and divided by n. Now this numerator has become covariance xy and denominator has become variance of x. So beta cap is covariance xy divided by variance of x. This is one formulation of beta cap. Now this summation xy by summation x square, it could be expressed as summation xy into under root summation y square and under root 1 by n. These two Aristotle terms we have taken in numerator, so that would be taken and in denominator itself divided by this summation x square could be written as under root summation x square under root summation x square. Now this 1 by n could be written as here n. And under root summation y square. It was numerator taken in just denominator, under root 1 by n, here it is 1 by n. Now if it is slightly rearranged, what we find, it is summation xy into under root summation y minus y bar square divided by n. This small y square has been expanded, and in the denominator under root summation x square under root summation y square and under root summation x minus x bar square and divided by n. Now this thing has become Karl-Pearson correlation coefficient. This is a standard deviation of y and this is a standard deviation of x. So beta cap has become r into sigma y divided by sigma x. So in the deviation form, beta cap could be expressed in various forms. This is summation xy by summation x square, or it is covariance xy by variance of x, and by slightly rearrangement we can express beta cap as r into standard deviation of y by a standard deviation of x. So this was how the just two formulations of least square method, one in the non-deviation form, another in the deviation forms, and this is how we explain the least square method. Now based on this method, various sums are there, which I shall be explaining in next class. For today's, this is all. Thanks.